All right, welcome back to the section 4.3 video. In this video, we're going to be taking a look at our third case of the constant coefficient solution where we have some complex roots when using the auxiliary equation. So when the auxiliary equation provides two complex roots, that would look something like alpha plus or minus beta I, some imaginary complex root. We would use this solution. Y equals e to the alpha times x, all times c1 cosine of beta x plus c2 sine of beta x. So we would try to set up the same exact way. So let's go ahead and get started on example 5. So we have y double prime minus 4y prime plus 5y equals 0. So let's try it the same way. A equals 1, b equals -4, and c equals 5. Okay, and recall the auxiliary equation, you know, excuse me, a m squared plus bm plus c equals 0. So what I would have here is m squared minus 4m plus 5 equals 0. And so you would think to yourself, what does this factor into? And so clearly it doesn't factor cleanly off the top of our head in any type of techniques that we use. So this can't factor. So maybe it's a square root, maybe it's something we don't know yet. So our intuition here is to use quadratic formula. We use quadratic formula to find roots. And so, quadratic formula, I'm gonna write m, like m as opposed to x, but m equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so let's go ahead and figure out what our roots could be. So m equals -4 plus or minus square root of -4 squared minus 4 times 1 times 5 all over 2 times 1. Okay, so if we clean this up a bit, this is 4 plus or minus the square root of, looks like it would just be -4 inside, all over 2. Oh, so we have a negative inside of the square root. So what happens when we have a negative inside the square root? Well, the way we could write that is square root of 4, and negative inside of a square root is I. Because if you could recall from your previous math that like square root of 1, -1, or I equals square root of -1. So we can just take that out. And square root of 4, well, that just becomes, excuse me, that just becomes 2. So it's 4 plus or minus 2i over 2. And the way we would write this or think about it is 4 over 2 plus or minus 2i over 2. And so things cancel out. We get 2's cancel out. 2 and the 4 becomes 2. And so what we get is 2 plus or minus I. And so if you could recall from up above that roots are of the form a plus or minus bi. So my roots are alpha plus or minus beta I. So 2 is my alpha, and there's like an invisible 1 right here. That would be my beta. Beta wouldn't be I, it would be the constant attached to the I. So I will take my alpha and beta, throw them back into the solution where they belong and write up our general solution. So therefore, y equals e to the 2x all times c1 cosine of, we could write 1x if you want, plus c2 sine of 1x. If you want, it's up to you. Without the x is fine, or without the 1 is fine. But yeah, this is my alpha, beta, and beta. Okay, so that's our first example of complex roots. Okay, so that's our answer. Maybe I could clean this up a little bit more without the 1. So, so as we write it down here, y equals e to the 2x c1 cosine of x plus c2 sine of x. I just prefer that. Okay, so that's example 5 for imaginary or complex roots. Why don't you guys go ahead and pause the video and try out example 6. Okay, welcome back. So hopefully you tried this problem out and you got the same results. So one thing you have to be careful here with is that there's no y prime. So you need to account for that y prime. And so since there's no y prime, that means a constant attached to it has got to be 0. So b equals 0. So when you try to solve this auxiliary equation, you just have n squared plus 9 equals 0. And that should give you n plus or minus 3i. So just be careful there as well, meaning that there's no alpha. So it's like saying 0 plus 3i is our root. So that means alpha is 0 and our beta is 3. So when we plug these into our solution here, what happens is we get e to the 0x, and e to the 0 is just um, going to be, well, 0 times x is 0, so e to the 0 is just going to be 1, so that exponential term goes away. And so I'm just left with c1 cosine 3x plus c2 sine 3x. Okay, so that's another example and a good example of when y prime isn't present, what do we do? And a good example of when alpha isn't explicitly shown, that is just going to be 0. But okay, so that's it for complex roots. Um, Thank you for watching, and I'll see you in the next video. Take care.